In the last class we have discussed about electric field. In this class we will see a problem based on electric field. The problem is here, let me read out this. 2 point charges QA equal to 3 microcoulomb and QB equal to minus 3 microcoulomb are located 20 centimeter apart in vacuum. What is the electric field at the midpoint O of the line AB joining the two charges? If a negative test charge of magnitude 1.5 into 10 to the power minus 9 microcoulomb is placed at this point, what is the force experienced by this test charge? Now first we will write what are the given quantities and then we will try to find out the solution. So given two charges QA equal to 3 microcoulomb and QB is equal to minus 3 microcoulomb. So they are located 20 centimeter apart in vacuum. So R, the distance between them is 20 centimeter. Now we have QA, we have QB at a distance of 20 centimeter from this QA. QB. So the distance between them is 20 centimeter. This is the given thing. So the question number A, what is the electric field at the midpoint O of the line AB joining the two charges? Now we have to mark the midpoint O. So if this is 20 centimeter is R, so this will be R by 2, that is 10 centimeter. This also 10 centimeter midpoint. So point O is at a distance 10 centimeter from QA and also 10 centimeter from QB. Now find out the electric field at this point. We have two charges QA and QB. So let EOA is the electric field due to charge A. Let EOA is the electric field at O due to charge QA. Now what is the direction of this? So QA, it is plus 3 microcoulomb. So this is charge is 3 microcoulomb. So it is plus. So for a plus charge, the field is in a direction which is going away from the charge. If I mark EOA, it will be going away from 3 microcoulomb. It will be in this direction. EOA. Similarly, let EOB is the electric field at O due to charge QB. EOB is the electric field at O due to charge QB. So it is away from O or towards QB. Okay, away from QA or towards QB. Similarly at O, so this is the magnitude of QB is given, it is minus 3 microcoulomb. So for a negative charge, again the field is going towards the negative charge. So if I want to mark EOB, then again it will be in the same direction as that of EOA. So EOB will be also in the same direction. Therefore, so here we can write the direction of EOB is also towards QB or towards B. You can write towards QB or towards B, because we can mark these points as A and B. This point, if it is A, this point is B. So towards QB, or I can mark towards B also here. Here also I can write it as towards B. So the net electric field at O will be the sum of EOA and EOB. At O is EOA plus EOB. Because O is equidistant from QA and QB and the charges QA and QB are equal, the magnitude of EOA will be equal to EOB. O is the midpoint because O is the midpoint and QA and QB are of same magnitude. EOA is equal to EOB. First we will find out EOA or EOB, then you can multiply by 2 to find out the net charge. EOA is equal to 1 by 4 pi epsilon naught into QA divided by, it is R by 2 whole square, because we took R as 20, R by 2 is 10. Substitute the values. 1 by 4 pi epsilon naught is 9 into 10 to the power 9 and QA is 3 micro, micro is 10 to the power minus 6 divided by R is 10 centimeter, convert that into meter, 10 into 10 to the power minus 2 meter square. Simplify this, so 9 3s are 27, multiplied by 10 to the power 5 you will get. So cancel out 9 and minus 6 and also bring this to top, you will get 9 to 10 to the power 5 Newton per coulomb. EOA. Because EOA equal to EOB, net charge is EOA also equal to EOB, which is equal to 27 into 10 to the power 5 Newton per coulomb. Net field at O. equal to EOA plus EOB. Add them. (27 into 10 to the power 5 plus 27 into 10 to the power 5). 54 into 10 to the power 6 Newton per Coulomb. And this is directed towards B. Now what is the second question? The second question says, if a negative test charge is placed, if a negative test charge of magnitude 1.5 into 10 to the power minus 9 microcoulomb is placed at this point, what is the force experienced by the test charge? Now place a test charge of 1.5 into 10 to the power minus 9 microcoulomb at point 4. What is the force? We can write answer B. The force experienced by the test charges F is equal to the test charge, that is QT. I'll write QT, that is the test charge, or I will write it as Q, the magnitude of test charge, multiplied by net electric field. E as net electric field. I am writing this bracket because in the previous answer I have not written it as E net, or you can write Q test charge multiplied by field at O. Because we know force is Q into E, or E electric field is force by Q, force per charge. The magnitude of the test charge is 1.5 into 10 to the power minus 9 Coulomb. If you go back and see, it is 1.5 into 10 to the power minus 9. (1.5) into 10 to the power minus 9, and the electric field we got as 54 into 10 to the power 5. Simplify this, you will get force as equal to 8.1 into 10 to the power minus 3 Newton. (8.1 into 10 to the power minus 3 Newton). So this force will be acting. See, this is a negative charge. When a negative charge is placed here, at B we have a negative charge, so they both will be repelling each other. So the force will be acting along OA or towards A, because QA is a positive charge, So this positive charge will attract this negative charge. So here you can write the direction. So this is acting in a direction opposite to that of E, or the force is acting along OA. That means I'll write forces acting towards A. You can write any one sentence in a direction opposite to that of E, or the force is acting along OA, or the force is acting towards E. So this is how we solve the problem when two charges are given to find out the electric field. Once the electric field is at that point, you can easily calculate the force experienced by a test charge at that point.